Hi there and welcome to another short web snippet brought to you by the guys here at Innova Systems. My name is Matthew and I'm just going to talk you through a couple of the tools that are available to us within SolidWorks Flow Simulation that aid us in presenting our results and visualizing our results. So let's switch over and have a look at our model. Okay, so what you can see we've got here is a nozzle essentially with a corkscrew fin going through the middle, which is going to generate some sort of vortex flow through the center of this system. So ignoring our setup, because that's going to be subject of something else, we've got a number of tools here. The first is our 3D mesh. So if I first of all cut a section so we can have a look inside, and if I right click on the mesh here and go to 3D view, we've got the option to plot fluid, solid cells and partial cells. So here I'm displaying all of the partial cells with a green color. So if I hit OK, you'll see that we get a model which does seem somewhat crowded. You can't really get much information out of there. But one thing we can do is use the region option, and by specifying, so say bringing the Z max down to 0, you'll see we can cut that in half, and we can bring the Y max down to 0, and that's going to cut that into a quarter. And now we can come in and have a look at the walls and how the mesh is representing our geometry at the walls just there. That's one very handy visualization tool for our mesh setup. If I right click that and hide. One thing to remember is that that crop tool, if I open up our next cut plot, is something that we've got available to us in every plot type. So here we've got crop region again, and we can again specify a specific region for which to display our results. Now here with our cut plot, first of all I'm just displaying the mesh. So I've got mesh selected only and I'm displaying that as black. And if I just hit OK, we can see that we've got a 2D representation of the mesh, so it is a cut plot of the mesh. If I right click and go to play, we can drag that plane back and forth through the model and have a look at the mesh throughout the model, so not just on that one section, which is a really handy tool because it does simplify the view somewhat. Okay, if I stop that, we can now just hide it and have a look at our next cut plot. So if I edit the definition of this, you'll see that we're using the right plane in this case, and we're cutting a cross-sectional view. So I'm plotting both the vectors in this case and the contours. For the contour plot, I'm representing velocity with a total of 165 levels. The more levels you've got, the smoother those gradients will be. And in our vectors options, we've got velocity again, and we can specify spacing and arrow size options, and also the color. So if I just hit OK there, you can see the plot that we've got displayed on the screen here. And if I just click on the plot in the tree once, you see the arrow we get in the middle here. This allows us to drag the plot back and forth through the model and actually get more of a dynamic view of how that result is varying throughout the model, which is really nice. It's not always that clear what's going on just with the one singular section. Okay, let's hide that guy. And now finally I'm going to edit the definition of this other cut plot. And what you'll see we've got here is another contour plot based on the velocity. So if I hit OK, we can see the velocity distribution of the flow throughout the tube. But if I come back into that cut plot now, you'll notice that we haven't got any boundary layer display along the wall in the model. Now that's something that doesn't come on by default, but we can display it by checking this box in the options. So if I select OK, we can zoom in now and see the development of the boundary layer as we go through our model. So at the inlet it's very small, we've got some thickening, then we hit fin. Behind the fin we've got probably a turbulent boundary layer, so it's a lot thicker. Now while I've got this plot open, it's also worth noting that we can drag the maximum and minimum values of these axes around, so we can change how our results look. Now we can also, by clicking once, we can change this top value, say, to the maximum value present within the model, or we can also switch it to the maximum value present in this singular cut plot, which will only change it slightly, but that's a tool that's really handy for just touching up your results to display exactly what you're trying to convey. Okay, next thing we're going to have a look at producing our flow trajectories. So if I insert a flow trajectory just here, we can actually, instead of trying to find a face that we want to select for our flow trajectory, we can grab the bar just up the top here, drag that down and switch over into the tab for the flow simulation. And then we can actually use, say, our inlet velocity boundary condition, so the face that we use to specify that boundary condition, pull straight through into our set box. So we can use that as our inlet for the flow trajectories. So if I just stick 30 in there, and you'll see we've got a number of different options for the appearance of our flow trajectory. So we can use pipes, we can use lines, or we can use bands. So I'm going to use lines in this case, and it's worth having a look through those and seeing which one visually represents what you're trying to say best, and also which one's most attractive, because everyone likes to see an attractive picture of their flow results, and it's a nice thing to hand to a customer. So if I hit OK there, you see we've got a nice flow representation of the flow through our model. Now, if I turn the geometry off for the time being, you'll see that now, because of the scene that we've got in the background, our results aren't actually that clear to see. So one way that I prefer to show my results is by switching the scene to pitch black. And you see that everything shows up really clearly now. It's a nice vibrant image. And now if I switch to our particle study, so I'm going to go use the wizard and generate a particle study. And I'm just going to stick some values in here. So I'm going to use water. And for my inlet, I've actually already got a sketch that I've already generated. Now this sort of geometry can be added after solving. So once you've got your results, you can add another sketch anywhere in your model and use that as an inlet for your flow trajectories or your particle studies or for an XY plot. In this case, I've got this X shape just here. And if I check ideal reflection, so that all of the particles bounce off the walls, I'm not going to include any physical settings for the time being, and I'm happy with trajectories and statistics. So if I just hit run and then display our results, you can see we've got a very nice representation of these two sheets essentially of particles and how they move throughout the model. As always, we've got the option to animate those there. The next tool I'm going to show you is our report generation. So by right clicking on the report and going to create, we can generate our own Word reports, which is a really handy automated tool, which is really nice for conveying your results with numbers as opposed to just pictures. So I'm going to use a template, and you'll see here that I've already got an Innova Flow Report template set up. And what that's going to do is generate our Word report based on the template that I've already got there, so it's got a header, etc. So if I switch over to our Word report, you'll see that everything's pulled through, and we've also got all of the information from that study, so the system information, our general information, all of the setup information, all of our boundary conditions, etc., and also the results from our goals. Now you'll notice there aren't any images in here yet. Now it's really easy to pull those pictures through. If I move this out of the way, we can actually drag our model to a location that we're interested in, and by switching to the Pictures and Charts tab, we can simply click Add to Report, and by switching back over to my Word report now, you'll see that the image that we had on the screen there is what's now been added to the report. And we can do that over and over again with each of our cut plots. We can set it up exactly how we want it to look, and that's what will be pasted in. Okay, one final tool I'm going to have a look at is the animations tool. So here, right clicking on the animations and inserting, we get the animation wizard come up, and this is very similar to the animation wizard that you have in the standard SolidWorks interface. So all we need to do here, say for instance I'm going to hit play, and you'll see because we've got lines next to both the flow trajectories and the particle injection, if I hit play, you'll see that the particles will be moving, and we'll get a nice video that we can record and save and paste that into any document that we like. Okay, before I switch over and show you some of the videos, I'm also going to have a look at a transient analysis. So Here we've got a cut plot, but if I click play, you'll see that that plane is just going to drag back and forth through the geometry like we saw with the mesh previously. But that's not really that useful here. We want to see how this flow is varying with respect to time. So by bringing up the animations wizard again, I'm actually going to use the wizard tool within the animations wizard, and I'm going to delete all of the existing tracks. So this is going to remove the keyframes that I've already got, and I'm going to make sure that I select scenario, and that's going to bring through that time dependent result. So here we can see all of the keyframes for each of the different solve stages, and I'm just going to right click next to cut plot 1 and insert my first control point, and I'm going to drag that out to the full length of the study. So now hitting play, you'll see we've got a nice transient response. So now let's just switch back through to my PowerPoint, and you can see, so there, that's our first flow visualization. It's a really nice visual way to present your results to someone. Switching over, so saying here we've got turbulators that you might see on the top of a car or something like that, and running the study. We've got, first of all, our cut plot moving down through a turbulator, and then we can change the angle for a front projection and see the flow trajectory. Change the angle again and repeat the flow trajectory play. And you see we can keep changing that angle and repeating it, and setting up the animation beforehand. You can get a really nice video. So there you can see the particle study as well. And now you'll see our transient analysis. So now you can see how nicely we can portray that von Karman vortex shedding from the back of that cylinder. That's about all I've got time for. So if you want to get in touch with us, you can visit us at www.innovasystems.co.uk. You can also pop an email over to the guys in the support office, or you can give us a call on the number on the screen.